the remote NMR project. I think at your first workshop, you heard a bit about this from Antonio Rosata from Florence. So I think our project's funded from the same budget that the eRImote is. We have a budget of about 1.35 million euros, and our project involves 26 partners from across Europe, which is shown on the map here. We started our project on the 1st of July. The project overall is coordinated by the group in Frankfurt, and then the group in Florence are the co-coordinator. And the funding comes from Horizon Europe, but for the UK partners, the funding has come from Innovate UK because the agreement between the EU and the UK hadn't come through yet to fund UK participants. I think an update compared to the presentation a couple months ago, we now have a website where you can learn more about the project, and it's also possible to follow the project on Twitter. Okay, so NMR spectroscopy facilities are actually very widely distributed across Europe, and that's unlike some of the research infrastructures in Europe in this other remote access project. So the map on the left only shows the facilities that are participating in the project. If you look at, say, the UK, which is where I'm based, there are actually at least 15 NMR facilities within the UK that have NMR spectrometers which operate in what we would call the very high or ultra high field range, which would be, say, 800 megahertz upwards. In the UK, the maximum is 1 gigahertz. In Europe, there are some 1.2 gigahertz spectrometers. So it's a highly distributed group of infrastructures. Some of them, like the infrastructure in Florence, provides transnational access, whereas many other infrastructures, such as some of the ones in the UK, only provide access within to users within the UK. So before the pandemic, it really was most NMR users just went to the NMR facility, sat down in front of the NMR machine and operated it in a sort of direct access mode for data collection. But when the lockdowns came and other travel restrictions during the pandemic, it made that in-person collection of NMR data either very difficult or impossible. So very quickly, a number of NMR facilities across Europe really came up with their own solutions on how to provide remote access. And in this project, we're really looking at all the solutions that individual projects or individual facilities came up with and trying to come up with a unified approach, identifying best practice for remote access. So these are some statistics. These were collected before the grant was written or during the grant writing process to really look at the effect of the pandemic on access to NMR. And the gray bars show like the typical access before the pandemic, and the darker gray bars are access during the lockdown. And so you can see there was a decrease in access, particularly as shown here on the right, which was access for external users. And that was really because travel became almost impossible in most countries. So the pandemic had a big impact on how NMR facilities were used, and it was important to very quickly try to come up with remote solutions. So based on the data that was collected from the 26 participants, the grant was written, and the overall goal is really to introduce remote measurement at all major NMR sites throughout Europe, and to provide a kind of protocol for doing this, so even small facilities who don't want to think about how to implement things can be given a set of guidelines that they can follow. And it will also ensure that we have a more uniform provision of NMR across Europe. And so the project is divided into 5 main objectives: standardized remote access procedures, so looking at what we're doing now and trying to come up with best practice. One of the real challenges, I think, is to come up with good ideas about how to ship samples between two facilities, and I'll come back to that a little bit later. Providing some training programs online to help users who want to use NMR facilities remotely, looking at fair data sharing and archiving of data, and generally data protection aspects of the project. And then finally, monitoring the carbon footprint of NMR facilities. And I think remote access can only really contribute to a decrease in the carbon footprint because it reduces the amount of travel. And I think currently some of the, or before the pandemic, some of the travel to particularly transnational facilities in Europe probably did involve flights on airplanes. So reducing the use of air travel would certainly contribute to a decrease in the carbon footprint. So we have these 5 work packages that are addressing these different issues or the different objectives that we've identified. And each of the work packages is led by a different participant in the project. And the leaders of each of these work packages make up a group that meets regularly to discuss progress of the project. And so I'm involved with work package 2, which is assessing the remote NMR landscape. This is a slide that you may have seen at the previous workshop, which was put together by Antonio, and it really shows the interconnection of the different work packages. So none of the work packages are really completely independent. I'm involved in collecting information about the current state of play for remote access, and then that's going to feed into work package 3, which is going to really put together protocols for best practice in remote access. So the work packages are very interrelated, and many of the 26 participants in the project are involved in several different work packages. Okay, so within work package 2, there are a number of objectives, and with these are associated a number of tasks. And what I've been focusing on so far are the first and second objectives. The first one is providing a detailed picture of the operation of NMR facilities in Europe during the pandemic. And so that's really collecting information from managers of NMR facilities. And then the second objective is to understand the user perception of remote access and to look at the stratification of users. And this is really to collect information about the experiences users have had in accessing facilities remotely, really to get their perspective in contrast to the perspective of the people who provided the access, but also look at I think this has already been discussed a bit in other facilities. Do you have, say, very expert users who are allowed to do almost anything with the equipment? And then do you have much more sort of routine users who maybe have restrictions on how they can access the facility remotely? Where the other tasks involve understanding how general data protection requirements are going to affect how we provide remote access and how we protect people's data and also make the data accessible. The fourth objective has to do with the shipping of samples from the user's laboratory to the facilities. And then the fifth task or objective involves the carbon footprint, which is really reducing user travel. In the case of the carbon footprint of the equipment, remote access doesn't really change the operation of the equipment, so there's not likely to be any change in the carbon footprint there. So for the collecting information from the facility managers, the users, and also information about sample shipping is going to be collected via online surveys. And then for people who complete the survey who are willing to be involved in one-to-one online interviews, they can provide their name and email address. Other people can do the surveys anonymously. So the first survey is aimed at the NMR facility managers, and we're collecting information about the facility, so the types of NMR spectrometers, how many spectrometers, what fields they operate at, and also the software that they're using at the facility. Information about how they've implemented remote access before and during the pandemic. For example, what software are their users using in order to get to remote access, how they're handling the samples, data security, interaction with users, and specifically bottlenecks that they've identified in providing remote access. As I said, the survey can be completed anonymously, but also there's the opportunity to provide contact information. And then the second survey is going to be for users of facilities, and this is really to get their perspective about their experience of remote access and how they've, with some specific questions about how they've sent their samples to the facilities for measurement. So as I said in the breakout group, what came as a real shock to me was that in order to do a survey, you have to get ethical permission. Certainly at the University of Oxford, they're very, very strict about what you can and can't do without ethical permission. Basically, you can't do anything without ethical permission. And so the survey's been delayed because it's still going through our Central University Research Ethics Committee. The basic problem is if you ask anyone for their name or email address, then that's collecting personal data, and then all kinds of ethical and data protection guidelines have to be adhered to. This is the first time I've ever designed a survey. I'm using some software that's freely available in Oxford called the JISC online survey software, which is actually quite easy to use and produces quite a nice looking survey. So for anyone listening today who might be interested to look at my survey and how basically what the implementation online looks like, in case any of you are also going to be doing surveys, then you can use this link, and then you'll be asked to log in. So you need to give a password, which is in capital letters R-NMR-Oxford, and then you can have a look through the survey. This is just a pilot version, so you're welcome to click any of the, you can answer the questions. The data isn't going to be collected in any way. Just don't put your name or email address in if you do have a look at the survey. So I would say that one of the biggest challenges for remote NMR access, and this may be true of some of the other methods as well, and this is getting the sample to the facility, and this is particularly true for transnational access, i.e. between countries. And often in the kind of NMR I do, which is say proteins, they have to be labeled with isotopes, and the samples can actually be quite expensive to produce. So you also have to be able to ship the samples back to the user. And this is something that's addressed in one of our objectives. And I think the difficulty compared to, say, shipping of crystals to ESRF is that in solution NMR, we're looking at solutions of molecules in quite fragile glass tubes, NMR tubes. And some samples can be flash frozen and shipped in a frozen form, but some proteins don't like to be frozen. If you then thaw the sample, you get precipitation. And so those samples actually need to be shipped as solutions, but say at colder temperatures. So because we're looking at solutions, that adds a complication. There may also be air sensitive samples, particularly in chemistry and materials applications. And so the samples may need to be kept in an oxygen-free environment. This just shows, if anyone hasn't seen, this is what an NMR tube looks like. And you almost certainly can't, or it's very dangerous to freeze the sample within the tube, because when it thaws, it will almost certainly break the NMR tube. So you might have to ship it in a form, in an Eppendorf tube, and then at the facility, they might need to transfer the sample into an NMR tube. We do have some capability for higher throughput. And nowadays it's possible to get these sample racks that hold 96 samples at once in shorter NMR tubes. And on the right here, that's a picture of something called a sample jet sample changer. And actually having a sample changer like this makes remote access in some cases easier than it would be if you're just being shipped individual NMR tubes. There's another type of NMR, which is looking at samples in the solid state. So here the samples are either powders or microcrystalline powders. This is slightly easier because these can be packed into rotors. And this is an example of what the rotors look like. Here's a 1 cent coin, and you can see some of these rotors are actually very tiny, but it's possible for sample shipping there that the rotors can be packed and then shipped to the facility with already in the rotor. But again, air sensitive samples might be a problem. So I think for our project, this is one of the difficulties that we have to deal with, and how to come up with solutions for the shipping of samples. So yeah, if you'd like to learn more about our project or to follow the progress of our project, because there will be updates, you can look at our website. You can also follow the project on Twitter. And again, if you'd like to look at the survey, you can use this link and then this password. And maybe just in the last minute, I'll give you a glimpse of what remote access to an NMR machine looks like. If I can get that to work. So this is basically what you would see if you sat in front of an NMR machine. You'd get a screen that looks a bit like this. There's a sample in there at the moment that's locked. But with a modern, this is a Brooker spectrometer. With a modern spectrometer, you can do almost everything remotely. The only thing that's more difficult to do remotely is putting the sample into the machine. So you need a local operator to do that. Everything else can be controlled via the software. So things like tuning of the probe, which used to be something you had to do at the machine, is now it's possible to do that remotely. So I think running of NMR experiments remotely is, or at least for solution NMR, certainly relatively straightforward. The challenge is that somebody has to put the sample into the machine, and that's where you need samples to be shipped to facilities, and you need some local facility staff to actually put the tube into the machine.